Hello there, it's Alana Taki, your friendly neighborhood statistics instructor, and I'm back to help you learn how to do a weighted mean or a mean of grouped data with your calculator, with your TI-84 to be specific. So here I have an example where I have a student, Ashley, who took 4 classes in the semester. She got a 4.0 in her 4-credit statistics class, of course, a 3.0 in her 5-credit chemistry class, a 3.5 in her 2-credit fitness class, and a 2.5 in her 3-credit English class. What is her GPA for that semester? Now you can do this by hand following the formula, which is you'd multiply each weight times its value. So you take 4.0 times 4, 3.0 times 5, 3.5 times 2, and so on. And then you could find her GPA by dividing by the weights, i.e. the credit hours she took that semester. Now you could also do it using your calculator. So if I go to Stat and Edit, now remember to get rid of old data, you press Clear, Enter. Go up. So I'm going to go to the left, go up, press Clear, Enter. All right, so let me pull this aside for just a second. All right, so she has a 4.0, a 3.0, a 3.5, and a 2.5. Now, if I just did one variable stats right now, it would treat the 4 classes like they were equal. But that's not really fair. The 4-credit stats class is worth 4. The 3.0 in her chemistry class is worth 5 credits. 2 credits for her 3.5 fitness class, and a 2.5 in her 3-credit English class. So then, let me bring that back. We want to do stat, calculate, one variable. We're going to say L1 is where our information is. But my frequency list is my weights, right? How weighted my categories were, which in this case would be credit hours. So that was L2. So I get down here to calculate and I press enter. And for just a moment there, you could see L1 comma L2 was kind of there for a second. That's the old way you would have to type it in the old operating system. The new operating system, it figures it all out for you, and that is 3.25. So again, stat, edit, I put the values in L1, the X values. I put the weights or the frequencies in L2. Then I go to stat, calculate, one variable. L1 is my list. L2 is my frequency list. And I go down to calculate and press enter. And there you have it. Okay, so now how does this change for a table of data? Well, it doesn't really. This is 2. Let me put these in here. There's 2 with 0, there's 2 with 8, and there's 2 with 10. This is Scrabble. So the 2 blanks are worth 0. Z and Q are worth 10, so there's 2. And J and X are worth 2, or with 8, so that's 2. So what you can do is you could fill in those values in the calculator. So stat, edit, up, clear, enter, up, clear, enter. And I could type the point values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Now we have to put the frequencies, i.e. how common these tiles were, in the other column. Let me make this go away for a second. So there were 2 tiles worth 0 value, that's the 2 blanks. 68 tiles worth 1 value. All the vowels, the R, S, T, all that stuff. 7, 8, 10, 1, 0, 0, 2, 0, 2. All right, so I have in all the frequencies right here. Then to find the mean and the median, what I could do is I could say stat, calculate, one variable. And again, it would be L1 and L2 because I want the calculator to recognize that L2 is where my frequencies are, i.e. how frequent was 1, how frequent was 2, and so on. And I'll get that the mean is right up at the top. That's a 1.87. Right there, 1.87. And the median, I'll go down with my down arrow to see it. It's right there, it's 1. So the mean would be 1.87. And the median would be 1. All right. Now mode, again, the calculator doesn't find that. We learned that earlier. But you don't really need a calculator on this one. Look, which one occurs the most often? That's the mode. So if you look at the 100 tiles that are in Scrabble, by far the greatest point value occurs for number 1, right? The vast majority of the tiles are 1-point tiles. All the A's, all the E's, all the I's, all the O's, all the U's, S, R, T, right? Those are all worth only 1 point. N is only worth 1 point. L is only 1 worth point. The most frequent letters are only worth 1 point. So that happens way more than anything else. Alrighty. So that would be, in case you're interested, the mode. But the calculator doesn't find it for you. You just have to find that for yourself. All right, what about down here with this grade one? All right, so I have a student who has these grades according to this distribution, and you'd have to figure it out. So let me go to Stat, go to Edit, go up to the top, Clear, Enter, go over here, Clear, Enter. And I would enter those values. So let's see. For the online homework, the student has 75.4. It's right there, 75.4. Actually, I'm going to make this kind of move over so we can see both the screen and the calculator at the same time. Okay, so 75.4. The in-class work, the student had a 90.6. And yes, by the way, this is actually a real student. His name has been changed to protect his innocence. All right, so 73, 74. And then the two projects, there's two of them, so 50 and 98. And then the final exam, which they got a 78 on. So this is worth 0.10, 0.10, 0.15. Now be careful of the projects because there's two of them. They together make 10%. So each one individually is 5%. That's 0.05. Oops. That was a mistake. If you're going to do decimals all the way through. If you're going to do whole numbers like 10, 10, 15, 15, 15, do them all the way through. You just have to be really careful to be consistent. So I'm using decimals the whole time here. If you don't like that, you can use 10, 10, 15, 15, 15, 5, 5, 25. Okay? Then go to Stat, Calculate, one variable, L1, L2. And there you go. There's that person's grade, 78.75. And for part B, if you want to fiddle around and saying what's the highest and what's the lowest grade possible, well, if you haven't taken the final yet, then you can fiddle around with the highest grade and the lowest grade for the final. So the highest grade possible is a 100. You could run it again. The lowest grade possible would be a 0, and you could run it again. Okay? All right, last but not least, what about for grouped data? That's much more difficult. So grouped data means that this is continuous data. This is really 49.999999, but nobody ever writes it like that because that's annoying, right? So we stop at 49 because we're lazy, but it's really 49.99999 forever repeating. This is 59.999 forever repeating, and so on. Calculators can't handle that. So if I go to the top to my calculator and I say, Clear, Enter, and I want to enter a value of 4249, the calculator's not going to know what I want. If I go 40-49, it thinks I mean 40 subtract 49, which isn't what I mean at all, and it's never going to work right. So what I need is a single number that will represent this value really super well. So think about what this means. This means 49 all the way up to 50, but not including 50, right? So if you were going to do a histogram, the first bar would be 40 to 50, and the next bar would be 50 to 60, and so on. So to find the midpoint, what you do is right down here. You take the consecutive lower class limits, you add them up and divide by 2. You can actually do this in the calculator. So let me show you the screen. So if I say, clear that out, delete. If I say parentheses 40, that's the first class's lower class limit, plus, now my next class's lower class limit, first class was 40, the next class's lower class limit is 50. That's what consecutive means, the next class. So I would say 40 plus 50, close parentheses, divide by 2, and I get 45. Now if I was going to do it again, 50 plus 60, because the next one's at 60, close parentheses, divide by 2. Now you might notice these are 10 apart, which makes sense because look, 40, 50, 60, they're all 10 apart. All right, so if they're all 10 apart, then won't that just make all these 10 apart? And the answer is sure that will. So you go Plus 10 is 65, plus 10 is 75, plus 10 is 85, 95, 105. And you stop where the last class would be. So the last class is from 100 to 109.999999999. Therefore, the halfway spot would be 105. All right, so we have our midpoints. Let me type those in one sec. There, we've got those in. I'm going to make them a slightly different color. Ooh, that's too light. How about blue? There we go. All right, so now find the midpoints. We did that. And then population sample, all that good stuff. And then what you want to know is, on average, how long are you having to wait? This is the time between eruptions, how long you have to sit there and wait between the eruption and the next eruption. So what you want to do is go in here and enter those other values. So 8 times, they'd only have to wait around 45 minutes. 44 times, you'd have to wait around 55 minutes. 23 times, you'd have to wait around 65 minutes, and so on. All right? So then, to find the mean, you go stat, calculate, one variable, L1, L2, all that good. That is good, I should say. All right, 74.85. There's your mean right there. And it actually wants the standard deviation as well, and you can see that right down here. We're not going to get into it too much about whether it's S or sigma at this point, but suffice to say it's about 14.7, right? I guess we'll talk about it later, but for our purposes, we'll say that it's S, because that would mean that it is the sample, which this was a sample. Old Faithful's been erupting for a long time. So you don't want to act like the 200 eruptions we had here was all there was. Oh, what was that? 74.85, right. And this is minutes, right? So on average, you're going to have to wait 74.85 minutes. Oh, I'll be right back. There, I made that bold. And that would be that. And then, oh, it asks for the median as well. So let's go back and look in here. The median. The median is down below. There it is, 85 minutes. So the median is 85 minutes. So a bit of a difference. It's a little bit skewed left. Now the variance and the standard deviation. Well, the calculator gives us S. The calculator tells us that S is about, there it is, 14.716. So 14.716 minutes. That's the standard deviation. So the variance would be S squared. So you take 14.716 and you square it. So that would be that squared, which is, I don't know, but I'll make my calculator find it. Let's see here. Oh, don't forget, we can still use the variables number 5, and then there's SX number 3, and I square it, enter. So 216.56. And again, it doesn't really mean much to us in terms of units at this point. That's not what variance is useful for. Variance is useful for some higher level stuff. It has to do with the mathematics of something that's always positive, like variance is easier to work with. All right, so now we know how to find the standard deviation and the variance. This particular data set, not surprisingly, was a sample. That's why I used S. If it was a population, I would have used sigma. So it just depends on the problem, but this is totally from data. So, and this is not all there is. There's a much larger group of times between eruptions that we're not getting. So this is a sample, therefore I use S and S squared. All right, that's how to find everything with the TI-84. See you back here for more videos.